Okay, we are back to finish our examples. We have 3 more to go and then just a couple things in the table to fill out. If we look at letter C, we have 2y equals 6x minus 22 and negative 3x plus y equals 2. Now, there's a couple of things you could do here. We want to get one variable by itself. I feel like most of us would want to solve for this y, which I'm going to do. But another thing you could do if you wanted to is take this first equation, and if you divide everything by 2, you would also have something that says y equals. But I'm going to stick with what I said in the beginning. So this first equation here, if I want to solve that for y, I'm going to need to add 3x to both sides. And that gives me y equals 3x plus 2. Okay, so get rid of that. And now I can plug the expression 3x plus 2 in for y in the first equation. So I will be taking 2 times 3x plus 2. That equals 6x minus 22. All right, looks like I need to distribute on the left. That gives me 6x plus 4 equals 6x minus 22. Now, many of you might see something right now and notice that we have a 6x on each side, which proposes a little bit of a problem, maybe. If we wanted to move 1 to one side, we would subtract 6x on both sides. Well, what that does is it cancels our variables all together, and we end with 4 equals negative 22. We had an equation like this on the homework a couple days ago, where we end up with something that is not true, and there's no more variables. When that happens, that means there's no solution. Okay, and that's because this expression is not true. Okay, so when we end up with something like this with no variables and the end result is not true, that means no solution, which means there's no intersection point. And many of you guys would know that means parallel lines. All right, so we're done with that one because there's not a solution. Moving on to letter D, again, we do not have either equation that's solved for a single variable. So various things you could do, but maybe you see what I see. This first equation has this y, and if we just add 5 to both sides, that would get rid of that 5 over there, and I would have y equals negative 1/2 x plus 5. That I can then plug in for y in my second equation. So I have 3x plus 6 times negative 1/2 x plus 5 equals 30. I'm going to distribute that 6, so 3x, 6 times the negative 1/2, half of 6 is 3, multiplying by negatives will be a negative 3x, plus 6 times 5 is 30, equals 30. I have 3x minus 3x, and that cancels out, and what I'm left with is 30 equals 30. So a similar thing happens here. I lose my variable. But a different thing is that 30 does equal 30. That is a true statement. Whenever we end up with no variables left but a true statement at the end, that means there are infinitely many solutions. Okay, so we can't just give 1 point. And if you remember from geometry, when there's infinite solutions, that actually means that the lines coincide or they lie on top of one another. All right, one more example. Letter E, 3x equals 6y minus 3, 5x plus 7y equals 29. None of these look that awesome to rewrite, but what I do see in the first one is that every term is divisible by 3. So they have a common factor. So what if I just divide all those by 3, because then I could get x by itself. So I'll write that over here. So I have, oops, 3x equals 6y minus 3. And if I take that and divide each one by 3, which is a legal thing, as long as I'm doing the same thing to everything, I get x equals 2y minus 1. So x equals 2y minus 1, I can take that 2y minus 1 and stick it in for the x in the second equation. This is the first time we've solved for x. You can do that anytime you want. That just happened to be how these worked out. So 5 times 2y minus 1 plus 7y equals 29. Distribute my 5, 10y minus 5 plus 7y equals 29. I've got 10y plus 7y, that's 17y minus 5 equals 29. Add 5 to both sides, 17y equals 34, and divide by 17. 17 is half of 34, so y equals 2. Y equals 2, and I have an equation for x. So I go ahead and plug 2 in for y here. X equals 2 times 2 minus 1. Just put that 2 right there. X equals 4 minus 1, so x equals 3. So the point of intersection is the point 3, 2, and that has a solution. All right, as we've seen in these problems, some of the problems had one solution. We also had a case where there was no solution, and then we had a case where there were infinitely many solutions. We're going to fill out, you can have one, no, or infinitely many. So we are going to fill out how we know this happens. If there's one solution, that means we end up being able to solve for x and y. So we can solve for x and y, and then our answer is always going to be the point xy. When there was no solution, we ended up with an untrue statement. For example, something like 24 equals 7. That is not true. That means there's no solution. Infinitely many solutions, we ended up with a true statement. Like 5 equals 5. That is true. Infinitely many solutions. Okay, that is systems of equations. I hope you enjoyed it. See you tomorrow.